in this session, so we are going to discuss something about distributed systems concepts. In the distributed system concepts, fault tolerance and security. So fourth unit. So already we discussed about unit 3, 2 on 1. So based on the basics and then how resource management and the distributed class, these concepts are we have discussed in the previous classes. Okay. So today we are going to discuss about the fault tolerance and security. How the fault tolerance will be achieved in distributed transaction, distributed systems, and how it provides the security. So these are things we have to discuss in the this unit. Okay. So in the fourth unit we have fault tolerance services, and then atomic computer protocols, concurrency controlled in distributed transaction, distributed deadlocks, transaction recovery, overview of security techniques, access control, cryptography algorithms, and workflows. So these are topics I want to discuss in the fourth unit. Okay, fault tolerance and then how it provides the security to the users. Okay, and then next one, fault tolerance services. So fault tolerance services means distributed system provide the uninterrupted services to the users. That's the concept of fault tolerance services. So fault tolerance is nothing but it ensures that uninterrupted service will be in distributed transactions. So that's a fault tolerance services. So fault tolerance simply means a system's ability to continue operating uninterrupted dispute the despite the failure of one or more of its components. So this is true whether it is a computer system or cloud cluster or network or something else. So fault tolerant services are obtained by using the replication concept. Okay, by using multiple independent servers replicas, each managing replicate data, help in designing a service which has itself a graceful degradation using the partial failure and improve the overall server performance. That means it provides the uninterrupted services. So fault tolerance is nothing but it provides the uninterrupted services. At the same time, it is achieved based on the replication concept. So it is achieved based on the replication concept. So based on that, we can improve the overall server performance. That's why we are sending the request to the distributed systems. It provides the resources. It send the response to the users based on replication concepts. So in that we have this is the concept. We are sending the request to the web server. Here load balancer is available. So based on we have many web servers. Based on that we are sending the request. It send the response whether it is available or not. If it is not available means the load balancer can send the standby web server to get the data and send back to the user. That's a web application. That's a fault tolerance concept. Okay. So in the fault tolerance service model, have two types. One is a passive replication and also active replication. The passive replication is nothing but so only one replica manager can perform the operations, and the remaining replica managers or secondary replica manager can store the data only. Okay, so that is a passive replications. In that, so we have from the client side, we have front end communicate to the primary replica managers only, and then the primary replica manager executes the operations and sends the copies of the updated data to the backups. So if the primary fails, once one of the backup is promoted to act as a primary, that is called as a passive replications. Okay, so fault tolerance means uninterrupted services will be provided. That means for sending the request to the web server, if any one web server or replica manager is failed to respond means the any other replica manager can act as a primary and send the response. That's a passive replica manager. We have diagram, you will easily understand. Okay. So in that we have this is the diagram of passive fault tolerance, the passive replica managers. In that passive replications, the passive replications we have the this is client front FE is nothing but a front end, RMS is nothing but a replica manager, is a primary replica manager. This only perform the operations. If there is any problem with the primary replica manager, any other replica manager can act as a primary and perform the operation. That is called the passive replica manager. Okay, so we are in that we have there are many operations. Okay, so totally 5 operations in the fault tolerance in the passive replications. One is a request, coordination, execution, agreement, and response. Request is nothing but a front end issue the request to the primary replica managers with the help of any one unique identifier. That is a request. Coordination is nothing but the primary replica manager takes the request and checks if it sets the unique identifier, if it is already executed and send the response. If it is not executed, it process and send the response. Okay, that is a coordination concept. That means the primary takes each request atomically in each in the order in which it receives. It checks the unique identifier in case it has already executed request, and if so, it simply resends the response. Okay, so otherwise, if it's not already executed, means go to the next operation execution. The primary execute the request and stores the response. Okay, the primary can execute the request and store the response in the primary replica manager. So after the next one, agreement concept. In the agreement concept, agreement operations, so it sends the response to the requested front end. Okay, if the request is an update, then the primary sends the updated state to the front end. Okay, that's a response and the unique identifier to all the backups. The backup sends an acknowledgement to the primary replica managers. Okay, so another one is the response. Response is nothing but the primary replica manager can the response to the front end, which grants the response back to the clients. That's a diagram. This diagram clearly explains the operations. The client can send the request to the browser. That's a front end. The front end can send the request to the primary replica managers. The primary replica manager is checks the agreement concept, checks, and if it is already executed, then send the response to the front end and to the client. Okay, if it is not executed, means it perform the execution. Otherwise, it perform the operation and sends back to the backup data to the another replica managers. In case if the primary replica manager is failed to respond, means any other replica manager can act as a primary and send the response to the front end. Okay, that's a passive replications. In that, only one replica manager can act as a primary replica managers. Okay, can only one replica manager can send the response to the requested front ends. Okay, so that's a passive replication. Another one is active replications. Active replication is nothing but in the above model of replications. Um, in the active model of replication for fault tolerance, the replica managers are state machines that play equal roles and organized as a group. Okay, that means I'll explain one by one. That's the concept. Here we have three replica manager. All replica manager can perform the operation. That's the concept of active replications. Front end multicast the request to the group of replica managers, and all the replica managers process the request independently but identically and send the reply to the all the front ends. Okay, here we have the diagram. In the diagram we have client can send the request to the front end. Front end can multicast the request to the all replica manager. Here we have three replica managers. Okay, all three replica manager can send the response to the individually send the response to the front end. That is active replication. In the passive replication, only the primary replica manager can only send the response to the front end. Okay, in active replica, all the three replica managers can send the response to the front end. Okay, that is active replications. Okay, that's about fault tolerance concept. Okay, so another one in that also we have operations, same request coordination execution agreement response, the same as passive. In that request is nothing but a front end can reliably multicast the request. So in that passive only one request. In here with multicast the request to all the replica managers. In passive only one request is sent to the primary replica manager only. Okay, and then coordination agree on ordering of requesters, and then execution each executes the request, agree no further action needed, and response each replica sends a response with unique ID to the front end. Okay, based on that the fault tolerance will be achieved in the both the concepts. One is a passive and then active replications. That's about fault tolerant services. So another concept is atomic commit protocol. So atomic commit protocol is nothing but it ensures that the atomicity property of the distributed database transactions. Okay, so atomic commit protocol is a protocol used by a database manager to ensure that all the sub transactions are consistently committed or aborted. So all the sub transactions are consistently committed or aborted. Based on that, we can achieve the atomicity property. Okay. So in this, each server replaces a local concurrency control to its own objects, which ensure the transaction is serialized locally as well as serialized globally. So, atomicity property. When atomicity concept, when a distributed transaction comes to the end, either all the servers commit the transaction or abort the transactions. Either at the final stage, either it commit the transaction or abort the transactions to ensure the atomicity property. Okay, that's the atomic commit protocol concepts. Here we have two concepts. one is a two-phase commit protocol and then three-phase commit protocol. So two-phase commit protocol. So two-phase commit protocol is nothing but two-phase commit protocol is designed to allow any participant to abort its part of transaction. And due to the requirement for atomicity, if one part of transaction is aborted, then whole transaction must be aborted. Okay, that's a concept of two-phase commit protocol. In the first phase, each participant votes for the transaction to be either committed or aborted. Okay, so once a participant has voted to commit the transaction, it is not allowed to abort the transaction. That's a if any participant is committed, it's not allowed to abort the transaction. That's the first phase. And the second phase, take the joint decision about the all the participants. If one participant votes to abort, then the decision must be abort the transaction. If all the participants vote to commit, then the decision is to be commit the transaction. This is the second phase. Okay. So in that we are going to have five operations. One is can commit message, do commit, can commit operations, so do commit operations, and then do abort operation, and then have committed operation, and then say get decision operations. Here we have so can commit. The coordinator can send the can commit message to the all the participants. That's the participant can reply the vote based on the either yes or no. After that, the coordinator can send the do commit transaction to the participants. If it is the vote is yes means it's in the commit spot. Okay, and then if it is no means do apart message. The call from coordinator to participants to tell the participant to apart transaction. That means if the can commit message receive the no means the participants can apart the transaction. That's a coordinator to participants to tell about apart your transaction. That's all. Okay, that's a two apart. And then have committed. So call from participant to coordinator to confirm that it has committed the transaction. Once it receive the all participants can send the commit. That's yes. What means the coordinator can confirm that it has committed to the transactions. Get decisions. Call from participants to coordinator to ask the decisions transaction when it has voted as but it has still no reply for the same some delay used to record from the server cache or delay message like that. Okay, this is a get decision. Okay, these are five operations. In that diagram clearly explain about the two-phase commit protocol. The coordinator can prepare the commit message and then first step send the can commit message to the participants. So participant can prepare the commit message. That means the participant can send the vote message either yes or no, either commit or commit or apart. Send the commit message means it send the yes to the coordinator. Coordinator can understand the participant is committed like that. Okay. After that, the coordinator can send the do commit message to the participants. So participants also committed because it send the yes message, so it's committed. And then participant, I am ready to commit with the transaction, so have committed. So coordinator can understand that one transaction is committed, so it perform the operation. That's a two-phase commit protocol. Okay, so and then three-phase commit protocol. So another three-phase commit protocol is nothing but here we have we can know about the participant status. That's a three-phase commit protocol. So three-phase commit protocol is an enhanced version of two-phase commit protocol designed to address the limitations of two-phase commit protocol, specifically the risk of blocking. Okay, three-phase commit protocol introduces an additional phase between prepare and commit, known as the pre-commit phase, to ensure the participants have enough time to respond, reducing the risk of indefinite blocking. Okay, so in the three phase, we have three. One is a prepare phase, pre-commit phase, and then commit phase. Before commit to the participants, the coordinator can know about the participants' status. Either participant is ready to respond or not, like that. Okay, that's a three-phase commit protocol. So based on that, we can achieve the indefinite blocking of process. That means if any coordinator can send the commit message to the participant. Participant is committed with participant is busy with another work means, so participants cannot send the response. So for that, initially it send the pre-commit message. Okay, that's a that is the three-phase commit protocol. So based on that, we can reduce the risk of indefinite blocking. Okay, okay. This three-phase commit protocol. So this is a diagram. So coordinator can send the request to the prepare vote for the participants. That means either participant is available to send the response or not, like that. Okay. So prepare to request vote and then participants can send the yes or no vote to the coordinator. So for vote cancellation, vote collection phase. Then that coordinator can collect the votes from the participants. So participants are ready to respond, like that. So after the coordinator can send the prepared to commit message to the can commit message to the participants. So participants can send the either yes or no vote. There is a prepared message to the coordinator. So again coordinator can send the commit initialization to the participants. So participants can send the committed transaction, committed concept from the coordinator. So I am committed like that. So that's a concept in the three-phase commit protocol. The coordinator can know about the participant's status, whether the participant is ready to respond or is receive some other like that. Okay, so that is the three-phase commit protocol. Okay, thank you.